If given the equation of a rational function and you want to know the y-intercept of the graph, you do the same thing you do with any equation where you want to know the y-intercept. You plug in 0 for x. To find y-intercept, always plug in 0 for x. In this case, I would get y equals 7, 0 over 0 plus 5. 0 over 5 is 0. The y-intercept is 0. The x-coordinate of a y-intercept is always 0, but in this case the y value is also 0. In this one, to find the y-intercept, I plug in 0 for x. 5 over 0. That's 5 divided by 0. You can't do that. So there's no y-intercept. This one, plug in 0. Find the y-intercept. Every rational function, trig function, anything I do, I always plug in 0 for x to find the y-intercept. Because y-intercepts are a spot on the y-axis, a spot where if I'm on the y-axis, my x value is 0. Okay, so I plug in 0 for x. 0 plus 0 over 0 minus 16. 0 over negative 16, 0. My y-intercept is 0. Again, the x-coordinate is always 0. In this case, the y happens to be 0. One more. I plug in a 0 for x. I get 0 minus 0 minus 12. 0 minus 0 minus 8. That's going to be 12 over 8. Which if I cancel a 4 out of both of them, I get 3 over 2. Apparently my y-intercept is 3 over 2. The x-coordinate, of course, is 0. Always for a y-intercept. X-coordinate is 0. Y-coordinate is whatever I get if I plug in a 0 for x. Now let's talk x-coordinate. Let's talk x-coordinate and domain at the same time. Both of those are going to require factoring. I look at my rational function and I factor the top. And I factor the denominator. Domain I get from looking at the excluded values. So domain I get from looking before simplifying. X-intercepts I get from looking after simplifying. So domain I get by looking at the excluded values, by looking at the zeros of the denominator. Zeros of my denominator are 4 and negative 2. These are the excluded values. These are the things that x can't be. My domain is everything except the excluded values. Everything except the zeros of the denominator. My domain is the set of all x's where x is not equal to 4 and x is not equal to negative 2. Or in interval notation, it'd be all the x's starting from negative infinity all the way up to negative 2 but not including negative 2. Also include everything between negative 2 and 4, not including negative 2 or 4. And then you also include, you union, everything from 4 to infinity, not including 4. Let's try and, that's domain. Let's try another one, domain. I factor. This factors to x minus 3, x plus 5, over x minus 1, x plus 1. Even if it's simplified, I wouldn't simplify yet. Domain comes from before simplifying. My excluded values are 1 and negative 1. My domain is everything except these. My domain is the set of all x's where x is not equal to 1 and also x is not equal to negative 1. Or in interval notation, that would be everything starting from negative infinity all the way up to negative 1, not including negative 1. Everything between negative 1 and 1, not including either. And then everything from 1 to infinity. So that's how domain works. And we'll practice that more in a second. But first I want to talk about x-intercepts. X-intercepts come from after simplifying. So I cancel out an x plus 4 and an x plus 4. And I'm left with x plus 3 over x plus 2. After I simplify, my x-intercepts are the zeros of the numerator. My x-intercepts are anything that makes x plus 3 come out to 0. So x equals negative 3. My x-intercept is negative 3 comma 0. In this one, x-intercepts come from after simplifying. So I cancel out anything, nothing to cancel. So my x-intercepts come from the zeros of this. they come from seeing what x minus 3, x plus 5, what x values make that come out to 0. And the answer is 3 and negative 5. I have two x-intercepts. One is the point 3, comma 0. The other is negative 5, comma 0. Because if the numerator is coming out to 0, then I'm going to have something that looks like 0 over something else. And a fraction with 0 on top comes out to 0. Okay, let's practice domain and x-intercepts with other things. Here, there's nothing to factor. So it's just this thing that's written in green, which was already written there. Weird. And domain comes from zeros of the denominator. Domain comes from excluded values. What makes the denominator 0? In this case, it's negative 5. So my domain is all of the x's where x is not equal to negative 5. The set of all x's where x is not equal to negative 5. In interval notation, that would be everything from negative infinity to negative 5, and also everything from negative 5 to infinity, but I don't include negative 5, so I do these parentheses instead of squares. X-intercepts come from after simplifying. There's nothing to simplify, so my x-intercepts are just going to be the zeros of the numerator. It's what makes 7x come out to 0. The answer would be x equals 0. So my x-intercept is 0, comma 0. This 0 meant I put a 0 here. X-intercepts always have a y value of 0 because they're on the x-axis where y is 0. This one, I factor. In this case, there's nothing to factor. Before I simplify, which there's not going to be simplifying, before I simplify, I think about zeros in my denominator. That'd be 0. My domain is everything except that. So my domain is the set of all x's where x is not equal to 0. Or everything from negative infinity to 0, union 0 to infinity, not including 0. That's my domain. I like to put a D just to remind myself that we're talking about domain. Then I simplify. There's nothing to simplify. And I look at the zeros of my numerator. There's not a 0 of the numerator. Nothing is going to make my numerator come out to 0. There's no solution to 5 equals 0. No x value suddenly turns a 5 into 0. So there's no x-intercept. One more. First step is I factor. Factor x out of the top because that's my GCF. And on bottom, I have difference of squares. My domain comes from zeros of my denominator before simplifying. So zeros of the denominator are 4 and negative 4. My domain is all of the x's, the set of all x's where x is not equal to negative 4 and also not equal to 4. In interval notation, that'd be from negative infinity to negative 4. Also negative 4 to 4. And also union with 4 to infinity. That's my domain. Then I would simplify if I could simplify. It doesn't look like it simplifies. Nothing crosses out. There's no common factor. So then I look at the, after simplifying, I look at the zeros of my numerator, which are 0 and negative 3. My x-intercepts are negative 3, 0, and 0, 0. This 0, it's always there. It's always there. But this I got from here, which I know you can't see anymore, but you remember what it said. And this I got from here.